Hey guys, we've had a look at independent events and we've found a couple of mathematical relationships that was helpful. So now we're having a look at dependent events. And of course, that just means that when one event occurs, it will directly affect the occurrence of another. So we're going to have a look at a couple of examples here. All right, so I've taken one that was really similar to the independent one. We have 2 red and 3 blue blocks. One is drawn, not replaced, then another drawn. So let's have a look at our first tree diagram, kind of like we did before. So we've got our first draw, second draw. All right, so in the first draw, we've got 5 outcomes. 2 red, 3 blue. So we've got our red and our red. And then we've got our blue, blue, and blue. But this time, if we draw the first one out and we don't replace it, that's going to leave us only with 4 blocks in the bag. So if we draw a red out first, we only have 1 red left in the bag for the second draw. But we still have all our 3 blues. So I've got 1 red and 3 blues left here. Of course, we'd have the same here. 1 red, 3 blues. It's getting all squishy and messy. Right, but what about if we had a blue drawn out first? Well, we'd still have our 2 reds, so I'll put my red, red. But instead of having 3 blues left, one of them is taken out. We've only got 2 blues left. So I'll put my blue and blue. And of course, I've got that here. I'd have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. What a mess. But if we have a look at what our sample space would be this time, we've got 5 events here, and off each one of those, we have 4 outcomes. So we'd have 5 lots of 4 events in our sample space. So this time we'd have 20 outcomes, not 25 like we had before. Once again, even though we've got less in the second draw, it's still tedious to draw a tree diagram. So let's have a look at the other option like we did earlier. All right, so let's have a look. First draw, second draw. All right, we're going to do a branch just for the different outcomes. So I'm going to have a branch for my red and a branch for my blue. If I draw red first, do I still have some reds and blues left to draw from? Yeah, even though I've got less reds, I still have reds and blues. So I'll have a branch for the red outcomes, branch for the blue. Now, if I drew a blue out first, when I draw it out for the second, I still have reds and blues. So I can do over here, branch for my reds, branch for my blues. All right, now let's go back and have a look at the probability. In the first draw, what's the probability that I draw a red out? It is 2 out of those 5. So if we've got 2/5 there, well, we know blue has to be 3/5 because they're complementary events. We know both those probabilities have to add to 1. All right, but now in the second draw, we have 1 less block. If the first one was red, we've only got 1 red left, haven't we? So we've got 1 in 4 that are red. There's our 1 in the 4. And of course, we have 3 out of those 4 blues. So I'll put 3 out of 4 there. All right, what about our, if we draw a blue first and we draw a red? Well, if we draw a blue first, we have 2 reds out of 4. So I'm going to write 2 out of 4. I'm going to write that as a half there. And I've got 2 blues out of those 4 if I drew a blue first. So I've got half, half. That's a 50-50 there. All right, so now let's come and have a look at our sample space. We've got red, 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 blue, blue, red, and blue, blue. But now we can use some of our little tricks with probability. To get a red, red, we know we can multiply those 2 probabilities. We've got 2/5 times 1/4. Having a red, blue would be 2/5 times 3/4. Having a blue and then a red would be 3/5 times 1/2. And then having a blue and a blue, we've got 3/5 times 1/2. I tend to set questions up like this, so I've got all of these things ready to work with when I need it. All right, so let's say the question was, find the probability of getting the same colours. I think we did this one before. All right, so what does that really mean? Same colours really means we've got a red, red, and a blue, blue. So that means probability of red, red, or blue, blue. Okay, so now if we want red, red, we multiply along our branches. So we can write that down. So our red, red is 2/5 times 1/4. Or if we want more than one outcome in our sample space, we remember to add that. So I'll put my plus there. And the blue, blue, over here we have 3/5 times 1/2. 3/5 times 1/2. So what do we got there? We have 2 out of 20 plus 3 out of 10, which of course is 6 out of 20. So we've got 6 plus 2, 8 out of 20 chance. Okay, let's go and have a look at one more problem here. All right. The probability that a woman has blonde hair is 35%. So I'm just going to write these down as we go. Probability of blonde, and because it's a percent, let's write it as a decimal, 0.35. So what's the probability that she does not have blonde hair, the complementary event? Well, of course, that's going to be 1 minus 0.35, isn't it? Which is, what, 0.65. All right, now let's have a look at what we've got. If she has blonde hair, then the probability that her children have blonde hair is 80%. But if she does not have blonde hair, the probability that her children will is 10%. So we definitely have dependent events here because the children having blonde hair depends upon whether the mother does. So let's go and have a look at what the tree diagram would look like here. So let's have a look at the mum and the child. Let's do the mum first. We basically have 2 outcomes for the mum. She can either be blonde or she can not be blonde, complementary event. And the probability that she has blonde hair is 0.35. Therefore, the probability that she's not blonde is 0.65. All right, now let's have a look at the next branch. If the mother has blonde hair, then her child can either be blonde or not blonde. The chance that she is blonde, if the mum was blonde, is 80%, so we can put 0.8 there. But if obviously if there's 80% chance she's blonde, there's 20% chance she's not blonde. All right, let's have a look at the next one. If the mum is blonde, there's 2 outcomes for the kids. They can be blonde or not blonde. So if the mum does not have blonde hair, then the chance that her child has blonde hair is 10%. So I'm going to put 0.1 there. And the chance that she does not have blonde hair obviously is 90%. So here's our sample space. We've got blonde, blonde, blonde and not blonde child, a not blonde mum but a blonde child, and a not blonde mum and a not blonde child. All right, so let's say we were asked for a question like this. Find the probability both the mum and the child are blonde. Okay, so let's go and have a look at our sample space. We find the one that we want. Mum and child are blonde, this one here. So we can then multiply our probabilities there. So we've got 0.35 times 0.8. Let's do that on a calculator. 0.35 times 0.8. And we end up with 0.28 or 28% chance. Okay. What if the question was the probability that they have the same hair colour? Then that would be, we'd be looking at probability of blonde, blonde, or not blonde, not blonde. So we'll have a look at our sample space here. blonde is up here. We just did that one. And not blonde down there. So using our probabilities, let me just write those, we would have 0.35 times 0.8, which we just did. Or, once again, we add those individual probabilities. 0.65 times 0.9. Just get rid of that up there. 0.9. And when we work that out, plus 0.65 times 0.9, we get 0.865, 0.865, or approximately 87%. There's an 87% chance that the child and the mum have the same colour hair. Okay, see you later, have fun.